Welcome to Science Tree channel, and today's topic is Standardize the given hydrochloric acid solution volumetrically. This is from class 10th, practical number 3. So the material required for this procedure is beaker, conical flask, pipette, burette and some other things as well. Let's discuss them one by one. So the number 1 is beaker. Beaker is used to measure things. In the same way, the conical flask is also calibrated and it is also used to measure the solutions. But please remember, the conical flask has narrow opening while that of as compared to that of beaker, it has wider opening. So most of the time the conical flasks are used to just mix or shake corrosive solutions. So that as it is the prolonged one and it has a thin, or we can say it has a narrow mouth, so most of the corrosive solutions will not move out of it. They will not move out of it easily while shaking or stirring. The next thing is pipette. Pipette is just like a straw shaped. It is opened from both ends. So now if it is opened from both ends, how we can take the liquid in it? Yes, we have to use the sucker on one end. With the help of this sucker, we will move the solution from one beaker to another with the help of or by pipette. Now what we have to do, we have to take the pipette, we have to put the sucker on it, and then we have to push the sucker in such a way that the solution from this test tube will move into it. And most of the time the pipettes are of 10 ml. So in this way, as the pipettes are calibrated as well, so we can also understand, we can also easily memorize that how much amount of solution is present in pipette and how much amount of solution is transferred from one beaker to another. So when we suck it, the solution will come into the pipette and then we'll move it to the other flask in which we want to transfer it. Other than that, we require funnel. Why we need funnel? We need funnel because we used to carry out all this titration process on a stand in a vertical position. So it's not possible to add HCl in the burette carefully without funnel. It may be possibility that it can be fall over here and there. So that's why we will put the funnel on the mouth of the burette, and when we add hydrochloric acid solution in it, it will smoothly goes on from it. And this is burette, one of the very most important apparatus of titration. Always remember that the solution which is present in the burette is known as titrant, a very important Viva question. And the solution which we take in the flask is known as titrant. So this is burette, it is also calibrated so that we can easily measure the amount of solution used in it or present in it. From where we get the solution which is present in the burette, we will definitely open the tap. Okay, this tap. Now it's up to you. If you will open it carefully and slowly, the amount of hydrochloric acid will drop down easily in the flask which contains sodium hydroxide solution. So this is all about the apparatus of titration. Now the one thing which is very important is chemicals. Please remember students, whenever you have to write it in the exam sheet, you have to give each and every heading carefully. Like you have to write the apparatus, then the material required, and then after that the chemicals. And what about the chemicals? Definitely we are dealing with the acid-base titration. So for this we need hydrochloric acid solution, sodium hydroxide solution. But what is this? Standard solution. Yes. As I have written standard solution, it means standard solution is that solution whose molarity is known. So this is also a very important Viva question. We know the molarity of one solution and we can easily find out the molarity of the other solution just by the process of titration. But one thing which is very important is indicator, which indicates that whether the reaction goes to completion or not. So here when we are dealing with the strong acids and strong bases, we used to take the indicator, that is phenolphthalein. It is colorless in acidic medium and shows pink color in basic medium. So that's very important thing which you have to be memorized, that in basic medium it shows pink color. Now what we have to do? We have to add this indicator in sodium hydroxide solution. Now this is the question for you. I am adding phenolphthalein in base. Can you please tell me that what will be the color? Yes, the color will be pink, because here I am talking about the base. So that's why the color changes pink. Now what will be the experiment? Experiment will be so simple. You just have to discharge this pink color, dark pink color to light pink. And this shows that the reaction has been completed. So now let's move towards the procedure. We have to do all the steps one by one and very carefully. No doubt, whenever we start the experiment, the first things which we have to do is wash out the apparatus. So I rinse the pipette first with the distilled water and then with sodium hydroxide solution. Now here why I have washed the pipette with sodium hydroxide solution, because I have to suck sodium hydroxide solution in the pipette. So that's why I also have to wash it out with sodium hydroxide solution. Then the conical flask, I have to rinse it with the distilled water. Then what I have to do? Take sodium hydroxide solution 10 cm cube or 10 ml with the help of pipette in a conical flask. I have shown you pipette as well. After that, you have to add 1 to 2 drops of phenolphthalein in it, and definitely after adding the phenolphthalein, the color turns pink. Then I have to move towards the burette, and I have to fill the burette with hydrochloric acid solution, and this is known as titrant. But before filling with the hydrochloric acid solution, I have to wash it with the distilled water and HCl solution. Then I have to hang the burette on a stand in a vertical position. Then I have to put the funnel on the mouth of the burette so that the hydrochloric acid solution can easily be moved into it. I use the tap at the base of the burette to allow the acid to flow in the flask. And please memorize that you can easily control the tap by yourself, so that's why please open the tap very carefully and very slowly, so that acid should be dropped into the base one by one, okay? Just like drop wise. It should not be like a whole flow or whole liquid is moving into the base. No, you have to enter it drop wise, one by one. Now when you are adding hydrochloric acid solution in the flask, kindly mix them well so that the reaction will take properly. Then I keep on adding acid till the color of the solution becomes light pink. It shows that the reaction is going to complete. And then I checked whether this pink color disappears just by adding one more drop of the acid. And this will be the end point of the reaction. After that, I noted down the final reading. Then I fill out the difference in initial and final reading of hydrochloric acid solution while titrating with sodium hydroxide solution. Definitely, I have to repeat the titration for accurate readings. Now, this is the apparatus which we have to set for the process of titration. Like this is an iron stand, and we have to hang the burette vertically with the iron stand. Then this is the flask in which I have to take sodium hydroxide solution, so that's why it is known as titrant. And in burette, I have to take hydrochloric acid solution, and it will be known as titrant. This is the tap which I have to open, and due to the addition of phenolphthalein indicator, its color turns to magenta pink. Okay. After that, when acids start entering into the base dropwise, what happens? The color will discharge from dark pink to light pink. So at that point, you have to note the reading. Now the question arises that from where I have to note the reading? Yes, you have to take the burette. The burette is calibrated. Initially, when you have just added hydrochloric acid solution into the burette, at that time the reading is 0. You have to fill up the burette up to 0. And then when I start using this HCl dropwise in titrating sodium hydroxide solution, what happens? It moves down, down, down. And I observe that when it reaches up to 10 cm3, the color turns to light pink. So I have to take the difference between the initial and the final reading. This is the chemical equation which is used for this process. I have used HCl and sodium hydroxide, a very famous reaction, neutralization reaction, and I will get sodium chloride with water. Now why I have written this equation over here? I have written it to find out the number of moles. I need number of moles in my calculations. So that's why I have to mention the chemical equation as well. This is the tabular form of all the data which I have taken from the burette. Now basically I have taken hydrochloric acid solution in the burette. I filled up the burette up to 0, and when I used it in titrating sodium hydroxide solution, the reading comes to 10. So basically 0 is an initial reading and 10 is the final reading. So there is a difference of 10 cm3. Again, I performed the experiment twicely. At that time, as the burette is up to 10 cm3, the hydrochloric acid solution in the burette is up to 10 cm3, and I will titrate it up to 20, and then the difference of 10 will come. Means that when it reaches up to 20, the color of the solution in the flask will comes to light pink or discharge. Similarly, I have again performed the experiment just to confirm that whether my readings are accurate or not. Now these 3 readings are showing the accuracy of experiment. Then I have to take the average. 10 plus 10 plus 10 give rise to 30 divided by 3, and it will give you 10 cm3. Now what is this 10 cm3? Yes, this is the volume. Volume of an acid used in titrating a base. So this will be V1. Now these are the calculations. You have to use the formula M1V1 over N1 is equal to M2V2 over N2. We are using acid and base, so one will be the acid and second will be the base. M1 is showing molarity of an acid solution. V1 is showing the volume of an acid solution. And N1 is showing the number of moles of acid in an equation. Now for that thing, I write the equation. M2, molarity of a base solution. V2, volume of the base solution. And N2 is the number of moles of base. So these are the calculation. Now let's put the values. We know that in whole this experiment, basically we are finding M1. M1 is hydrochloric acid solution and we don't know the molarity. So where we use this type of experiments or practicals? Yes, we use them in finding out the concentrations of acids. Okay? That how much molar of how much strength they are. Then V1 is the volume of an acid used, N1 is 1, M2 is molarity of the base, which is 0.1 cm3, V2 is the volume, and then N2 is the number of moles. Here I have put the values, and as I know that M1 is unknown, so I will move it out, and rest of the other things will get multiplied and divided, and I will get the answer 0.1 mole. So here it represents the molarity of sodium hydroxide solutions. Till now, how many headings I have discussed? I have discussed material required, chemicals, procedure, chemical equation, observations, and then calculations. So all these headings will carry marks. In totality, whole practical will carry 30 marks. One of the very important heading after that is result. It will carry 1 number. So whether you have performed the whole practical, you have written all the data on the exam sheet, but please remember, at the end of your exam sheet, at the end of your question, at the end of your paper, you have to write result. The molarity of hydrochloric acid solution is 0.1 molar. This statement is very necessary. Now, what are the precautions in performing this practical? So, students, before using conical flask and burette, these should be washed with distilled water. Number 2, during titration, place the conical flask on white tile to see the color change of the indicator clearly. Check that the burette doesn't leak. So these are the cautionary measures which you have to be taken in performing the experiment. Thank you so much. For more videos, keep watching. Have a great day.